Today's notes are on adding and subtracting rational expressions and simplifying complex fractions. As a warm-up, please simplify the following fractions. For number 1, because the denominators are the same, you can add the numerators together, so 3 plus 1, and then keep them over their common denominator. You can only add or subtract fractions if they have common denominators. So for number 2, I need to find a common denominator. Both denominators can be turned into 4, and that is achieved by multiplying the second fraction by 2 over 2. This will give me 3 over 4 plus 2 over 4, which will equal 5 over 4. I have to do something similar with number 3. I need to find a common denominator. My common denominator for this one is going to be 6. So the equation on the left needs to be multiplied by 2 over 2 to get a denominator of 6. And the fraction on the right needs to be multiplied by 3 over 3 to get a denominator of 6. So we end up with 4 over 6 minus 3 over 6. So 4 minus 3, which gives us 1 over 6. To simplify example 4, the first thing I'm going to do is unstack the fractions. So we're going to get 1 over 2 divided by 3 over 4. Then in order to simplify this, we're going to flip the complex fraction, or flip the second fraction, and multiply by the reciprocal. So I get 1/2 times 4 over 3. And I can multiply across to get 4 over 6. And 4 and 6 can both be divided by 2, which gives us our final answer of 2 over 3. For number 5, I'm going to start by simplifying the fractions in the denominator. So I'm going to multiply the fraction on the left by 3 over 3, and the fraction on the right by 2 over 2. That's going to give us 3 over 6 plus 2 over 6, which simplifies to 5 over 6. Then I'm going to unstack the fractions. So 1 I'm going to think of as 1 divided by 1, and I'm going to divide that by 5/6, which means I'm really going to take it and multiply by the reciprocal, which is 6 over 5. Their answer is 6 over 5. The next thing we're going to look at is simplifying complex fractions. So to simplify a complex fraction, you're going to first unstack the fraction and rewrite it horizontally, similar to what we did in warm-up number 4 and number 5. Then you're going to flip the fraction after the division sign and change it to multiplication. Then your third step will be to simplify it by factoring the expression and crossing off common factors. So by unstacking this, I get x minus 3 over 2x minus 8 divided by x squared minus 9 over 6x squared minus 96. So my next step is to flip the fraction after the division sign and change it to multiplication. So I get x minus 3 over 2x minus 8 times 6x squared minus 96 over x squared minus 9. Then I'm going to go through each part and see if I can factor it. So the first numerator I cannot factor, so I'm going to leave it as x minus 3. The first denominator has the greatest common factor of 2, so I'm going to pull that out. The second numerator I can pull out a 6, which leaves me with x squared minus 16. And the second denominator is the difference of two squares. It factors to x minus 3 and x plus 3. We do also have to factor the second numerator one more time. X squared minus 16 factors to x minus 4 and x plus 4. Now I can go about crossing off factors that appear in both the numerator and denominator. So I can cross off an x minus 3, I can cross off x minus 4, and I can simplify 6 over 2 to be 3 over 1. So the only thing left in the numerator is my 3 and the quantity x plus 4. And in the denominator, we're left with the quantity x plus 3. We're going to look at doing the same thing again here with example B. We're going to start by unstacking the fraction. So 2x squared minus 2 over x squared minus 6x minus 7, and we're going to multiply that by x squared minus 10x plus 21 over 1. Then I'm going to go through and see if I can factor these. So the first fraction, I can factor the numerator by pulling out a greatest common factor of 2, which is going to leave me with x squared minus 1. The first denominator, I'm looking for what two numbers multiply to negative 7 and add to negative 6. So I'll be using x minus 7 and x plus 1. Then in the second fraction, I'll be factoring the numerator, what multiplies to 21 and adds to negative 10. So we are going to use x minus 7 and x minus 3. And this is still over 1. We do also have to factor x squared minus 1 again. It becomes x minus 1 and x plus 1 because it's the difference of two squares. So I can cross off an x plus 1 in both the numerator and denominator and an x minus 7 in both the numerator and denominator. So I'm left with a 2, x minus 1, and x minus 3. Please look at example C on your own. We will talk about it in class. On the back or the second side, we're going to be looking at adding and subtracting rational expressions. So the first thing we need to do is find a common denominator. So you're going to factor the denominators and then multiply each fraction by the factor that is missing. So in example A, my denominator is already factored, so I need to find my least common denominator. And your least common denominator is going to be the smallest factor that both of the current denominators will multiply into. So 2 and 3 both go into 6, and x and x squared both go into x squared. So my least common denominator is going to be 6x squared. So in order to turn 2x into 3x squared, I'm missing a 3x, which means on the left side, I'm going to be multiplying by 3x over 3x. On the right side, in order to get from 3x squared to 6x squared, you're missing a 2, so you're going to multiply it by 2 over 2. This will turn into 15x over 6x squared plus 4 over 6x squared. And seeing as we have a common denominator now, you can keep the denominator and add the numerators together. 15x and 4 are not like terms. You cannot combine them together, so that leaves you with your final answer. You're going to start the same way for example B. I need to pull out a 2x from the second denominator in order to be left with my factor denominator, 2x times x plus 3, which will help me find my least common denominator. So they both multiply into 2x squared, and then they also would multiply into the quantity x plus 3. So my first fraction is going to be missing x plus 3 over x plus 3. And my second fraction is just missing an x. So we get 3x times x plus 3 over my common denominator. And you want to make sure that you're not canceling out the common factors yet, because that'll get you back where you started. On the right side, we end up with x squared over 2x squared, x plus 3. So we're going to simplify the numerators here. So I get 3x squared plus 9x from distributing the 3x plus the x squared that was already in the numerator on the right, and I can now put the whole thing over my common denominator, and I can combine like terms to get 4x squared plus 9x over my common denominator. You want to make sure before you decide it's your final answer that you can't simplify it any further. So for example, in the numerator, I can simplify this again by pulling out a greatest common factor of x. So I have x times 4x plus 9 over my least common denominator. And now because I have an x both in the numerator and in the denominator, I can cross them off, leaving you with a final answer of 4x plus 9 over 2x times x plus 3. Please try example C on your own. The steps for subtracting are going to be very similar. The only difference is when you're simplifying the numerators, you have to remember to distribute the negative to each term in the second numerator. So we're going to start the same way by factoring the denominators. So what multiplies to negative 12 and adds to negative 1, it would be x minus 4 and x plus 3. And in the second fraction, I can pull out a 3, leaving me with x minus 4. So your least common denominator the denominators would include a 3. They both can multiply into x minus 4, and both can multiply into x plus 3. So my first fraction is just missing the 3, so I'm going to multiply by 3 over 3. My second fraction is missing the x plus 3, so I'm going to multiply by x plus 3 over x plus 3. So I get 3 times 3x plus 1 over my common denominator minus 5 times x plus 3 over my common denominator. And I'm going to go through and simplify the numerator. So on the first fraction, I need to distribute the 3 to get 9x plus 3. In the second fraction, I'm going to distribute a negative 5, so I get negative 5x minus 15. And now I can put it all over my common denominator. And I'm going to combine like terms in the numerator to get 4x minus 12. You do have to try and simplify the numerator again by pulling out a greatest common factor of 4, because we want to make sure that the factors in the numerator don't factor out with any of the factors in the denominator, or cancel out with any of the factors in the denominator. In this case, they don't, so it leads us to our final answer. We will look at example B and C for subtracting, and all of example 4 together in class.